Hi, this is Mr. West, and today we're doing a Khan Academy tutorial on adding probabilities. We're going to go ahead and get started. A middle school principal has 80 keys on her keychain to distribute to staff on the first day. Of these 80 keys, 60 open classroom doors, 40 open the door to teacher's lounge, and 30 open classroom doors and the teacher's lounge. Using this information, answer each of the following questions. Let C be the event that a randomly selected key opens a classroom, and T be the teacher's lounge. Okay, so when it says what is P parentheses C, the probability that a key opens a classroom, it's just that. So P stands for probability, and then C is the condition that it provides. So that's opens classroom doors. So we need the total amount of keys. The total is 80, and the desired event, the likelihood that this event happens, is there's 60 of those classroom doors. So really we're just trying to find what is the probability of 60 divided by 80. Okay, so 60 divided by 80 is just 75%. And if you wanted, you could just type this into your calculator and do 60 divided by 80, and you're going to get 0.75. So this equals 0.75. So we know there's a 75% likelihood that it opens a classroom door if you select one of those keys at random. I think I typed it in. Yep, there it is. Okay, next one. P of T, so that's teacher's lounge. We are told that there are, 40 that open the teacher's lounge. That's supposed to be a highlighter. 40 that open the teacher's lounge. So really we're just looking for 40 over 80 for that one. Okay, and if you can guess, it's probably 50%, right? 40 divided by 80 is half, so that's 50%. So we can just type in 0.5. We don't need that 0.50. We can just type in 0.5. It's the same thing. What is the probability of P, probability of C and T? So both of those conditions happen together. Luckily, it tells us. Okay, a lot of people think that you're going to add these two together for and is the overlap. So if I'm seeing the word and in probability, I'm talking about the overlap. We can demonstrate this with a Venn diagram. So this would be like classroom doors on the right, and this would be the lounge on, I said the right, and I meant the left. And then in the middle would be both. Okay, so it's not exactly just adding these and these together. So be very careful on that. Luckily, it tells us, let me actually change the color. It tells us that it's 30. So we're just going to take this 30, and we're going to divide that 30 divided by 80, and that's going to give us our answer. This one's a little bit more tricky than the other two. So we have 30 divided by 80, and we get 0.375. So I'm going to type in 0.375. That's the probability that a key opens up both of those doors. What is the probability that a key opens a classroom or the teacher's lounge? So this one, what we can do here is, because we have or here, we are going to do a couple additional steps. Whoops, actually, I want to undo that. Okay, so or would mean we are combining, let me see here, just trying to get my color straight. We are going to be combining the lounge that happens or that the classroom happens. Now, take a look at this. I'm going to do the red and green. So we're going to do the probability that it's green or it's red. There's a problem with that though, and that is that as I do the red probability and then the green probability, I am double counting this purple area, the both, the and. Okay, so this is the process. The process is, I should have made this yellow, but let me change this to yellow just so we can be consistent with our kind of color scheme here. Either way, if it's yellow or red, we're going to have this overlap. So what we want to do is we are going to take our two probabilities here. Okay, so that was our probability that it opens the classroom, 75. Our probability that it opens the lounge, 0.5. And I know my colors are backwards, so that's okay. But we have to subtract our overlap, and our overlap is 0.375. So we have to subtract that away. So we're going to do P of C or T. It looks like I spelled court. equals the probability of C plus the probability of T, but we have to subtract P of C and T, okay? Because that's the overlap that we don't want to include twice. So if we exclude it and subtract it at the end, we're getting that OR condition. So what we need to do here is we're going to take 0.75, and actually this notation was incorrect, but the same thing applies. That was a slight tangent. 0.75 plus 0.5. And if you notice, if you add those two together, you're over 100%. Well, that's not the case here. Okay, that's not what we're looking for. We are going to do this one plus that one. Can't be over 100% probability. And then we have to subtract the overlap, which is 0.375. So 0.75 plus 0.5 minus 0.375. Okay, so I need my calculator for this. I'm going to do 0.75 plus 0.5. Really, I don't need a calculator, but just being extra cautious. 0.375, and I get 0.875. And that is my probability of having one of the two. And again, it doesn't make sense that I have over 100% chance with anything. Either 100% is the maximum probability. So just adding those, you see where the problem lies. We had overlap, double counting something, so we needed to subtract that away, and we get our answer. And we're done. Okay, so let's do this one now. A high school gym teacher randomly selects a group of 2 players from 3 students to demonstrate a basketball drill during class. The 3 students consist of 2 girls and 1 boy. Okay, so let's go ahead and make a quick diagram. So we have 2 girls. They're going to be red. And then we have 1 boy. He's going to be blue. Okay. The sample space of possible groups is listed below. Let A be the event that both students the coach chooses are girls, and B be the event that the first player is a boy. Okay, I'm just going to read through this one more time. Okay. Random selects group of 2 players. Okay, so there's possibility of 2, so we're going to choose 2 at a time and see the different combinations. Got it. All right. So what is the probability of A or B? The probability that the coach chooses all boys or a boy, all girls or a boy first. So A is the event that both students the coach chooses are girls, and B is the event that the first player is a boy. Okay, so let's go ahead and, it lists all of it for us. How about that? So what is the probability that the coach chooses all girls or a boy first? So we're just going to look here. This is easier than I thought it was going to be. Here I was getting all set up and everything. It lists everything for us. So we see here, I'm just going to highlight in red. So the first group is red, red. Then we have red. I'm just going to select all the girls' names. I think Davy is the boy. So, and then Andrea and Marta. Okay. Those are all the girls, and then we have, that's the boys. Okay. So what is the probability that the coach chooses all girls or a boy first? Well, what's the probability that it's all girls? Well, we have, right here is 1 and then 2. So we have 2 out of 1, 2, 3, 4, 5, 6. 2 out of 6. Okay, so that's 2 out of 6 possible combinations. And then boy first is 2 out of 6. Okay, this one, we don't need to worry about overlap just because we have all the possibilities in front of us here. So we can just go ahead and add these 2 together, and we're going to get 4 out of 6 total. Okay, again, there's no overlap because we see all the choices for us, and order matters. Okay, so Marta and Andrea, that matters. If we were to do this without this list, it would be a little bit more complicated, but we just need to type in 4 out of 6. We might even be able to type it as a fraction. Here we are, 4 out of 6, and we should be good to go. All right, there we go. A local gym offers its members the opportunity to choose between 2 fitness classes, yoga and dance. Of the 400 gym members, 300 regularly attend yoga, 80 attend dance, and 50 attend both. Using this information, answer each of the following questions. Let Y be the yoga, D be the dance, and let's get started. Okay, so again, this is kind of like our situation here. We have yoga. Okay, we have dance. And that one's a little bit smaller because, I mean, it should be way smaller because there's way less people. And then we have our both. Okay, and that's our both. Okay, and that's just to give you a visual representation of what we're trying to find. So probability that a gym member attends yoga. So if we have 300 yogis and we divide it by 400 total members, that is 0.75. And you type that in a calculator, you just leave it as 0.75. That would be 75%, but you leave it as a decimal. I forgot to mention that earlier. D is dance, so I'm going to do 80 divided by 400. That one should be 0.2. I like to double check. So we're going to do 80 divided by 400. 0.2. So that's 20%. So we get 0.2. Okay, and now the overlap. Okay, so the overlap, it tells us that it is, gotta scroll up. It is 50. So we do 50 divided by, that should be like 17%. So 50 divided by, nope, it's gonna be smaller than that. 0.125. So I do 50 divided by 400 and I get 0.125. Let me type that in, show you written out. So my overlap was green. And I have 50 divided by 400, and that gave me 0.125. Here we go, 0.125. Okay, so now I have all the conditions. That was like the easy part, just simple division. And now I have to figure this out. The probability that gym member attends yoga or dance. Okay, again, I have overlap here. That slight overlap. And basically what that means is, of those 80 members that are just dancers, okay, 50 of them also do yoga. Okay, so that's why it's like you can't double count them. If we just do 300 plus 80, we're double counting 50 people. So what you do instead, like I described earlier, is we're going to take 300 plus the 80. Okay, those are the total people, but we subtract the number of people that do both, so we don't double count them. And we divide that by 400. Or we can just take the probabilities, 0.75 plus 0.2 minus 0.125, and that's going to give us our answer too. So either one of these choices is fine. I'm actually going to go with the first just because it's fewer steps, and I've already done that work. So I get 0.2, and that gives me 95%, but then I need to subtract 0.125, and I get 82.5%. Or, written as a decimal, is just 0.825. And I'm done. Okay, last one. Ivan's favorite colors are blue and green. He's got these combinations of green and blue pants and etc. I'm going to read that later probably. Ivan selects one of these garments at random. Let A be the event that he selects a green garment and B be the event that he chooses a pair of pants. Okay, here we go. What is the probability that the garment Ivan chooses is either green or a pair of pants? Okay, so let's list all these things he has. He's got a blue shirt. Okay, so he's got a blue shirt. I'm just going to total number of blue things. So I'm going to go blue, and then we got green. And we'll go to total in a second. So total number of blue things. He's got 1, 2, 3 pairs of blue things. One green, one blue, one green, one blue hat, one blue pair of pants. Okay, and then one green shirt, one green belt, one green pair of pants. So that's 3. Okay, so he's got 3 blue things, 3 green things. Okay, so what is the probability the garment Ivan chooses is either green? Okay, so it's a 50% probability of green. So 0.5% for green. Okay, I hope you guys see that. The reason why it's 0.5% is because it's 3 out of a total of 6. Let's go to pair of pants. So how many pairs of pants? So now we're talking about pants over all the different types of clothings. So pants, let me change the color here. So we're just talking about pants. He's got 1, 2, 3, 4, 5, 6 things. So it's out of 6. How many are pants? We got shirt, hat, belt, pants, pants. Okay, so he's got 2 pairs of pants. That's 1/3. Okay. So it's 0.33 repeating, right, of pants. So 1/3. So I'm just going to keep it as a fraction, actually, because it's going to be easier because it's already written as a fraction over here. So I have 2/6 for pants. I have 3/6 for green. But the problem is there's probably overlap. Boom, right here. 1 is green and pants. So anytime we have this, we can add these 2 probabilities for or it gets complicated, right? 3/6 is green plus 2/6 is pants. However, because we have overlap, we have 1/6 that's green and pants. Okay, that's our P of A and B. So we have to be careful with that. Anytime there's overlap, you got to subtract it away. So 3/6 plus 2/6 minus 1/6, that's going to give us 4/6. Okay, what's the probability that one of those 2 things happens? It's a 2/3 probability. 4/6, I can reduce it. Okay, I just hope you know that 4/3 is the same thing as, 4/6 is the same thing as 2/3. And we're all done. Okay, so that's kind of difficult. If this is your first time seeing probability, probably should review some of my other videos that are more of an intro, but this is kind of tough stuff. Don't get frustrated. Take it one step at a time. The main thing from this video is the overlap. If you have any questions, leave a comment below, and I look forward to seeing you next time right here on Wes Explains Best.